Yo, what's up, everyone? I'm your host, Raphael, and I'm with my co-host, Mabin. Today, we have someone who's made a name for herself in the computer science field, and she's currently at York University teaching, Dr. Marzieh Ahmadzadeh. How's it going?
Hello, everyone. Hi. I'm good, and it's a pleasure that I can talk to you.
The pleasure is all ours, Professor. Obviously, we know you and a lot of our comp sci friends and know a lot about you as well because you taught some of our the in-depth Java courses. But to some of our friends and peers that do not know about you, would you care to introduce yourselves and tell us what you do and what you're all about?
Okay, so as you said, my name is Marzieh Ahmadzadeh, and I am assistant for professor teaching a stream at the Department of Electrical Engineering and Computer Science. I have a PhD in computer science, and also I am a professional engineer in software engineering. And the reason for that is because I have worked in industry for 5 years as a software engineer. Also, I have been in academia as a university professor for 15 years. And I have taught, a variety of courses, and here I am.
Well, that's a lot of experience and work under your belt.
Yeah, right.
Okay, so hearing that you're kind of all over the place with the computer science department, what made you interested or what made you stick to the software engineering part of that?
I guess for me, it's the nature of software engineering that requires problem solving. I like this challenge. In software engineering world, from the beginning, when you do requirement engineering, the software, you design a database, you write a program, you test the code. All these require some kind of problem solving. And this is something that interests me the most.
I see. Yeah, for us as, still developing computer engineering and computer science and software engineering students, that's the worst part. But we're slowly working through it and we're getting better. We promise you that.
Well, I don't agree. Just remember when you solve a problem, when you're given a problem and you think about it and you find the solution, how happy you feel.
Very happy, I will admit.
Yeah, you see, I like this happiness. I like this enjoyment. This is something that, makes me interested in software engineering.
Yeah, I can 100% agree with you, Miss. So as far our research goes on your different extracurriculars and different developments that you have done, we, as you mentioned, have seen that you have both worked in the industry and also have experience with the academia. So what was the process of that? So what type of jobs did you initially start off with in the industry?
Okay, so when I finished my BSc, I started to work in industry and as a software engineer, and I've been in different roles. I have been, a database designer. I have been, software developer, a tester, and even it was my job to maintain the system. So I have actually experienced all the activities in software engineering. And for a limited time, about a year, I had a chance to manage a project. So I've been project manager as well. So this is the thing that I've done in industry. And then I went for graduate study, and this is where my academic job started. You see, these two are different. In industry, you work with, you need to develop a software. You need to do the activities that related to developing the software. But at university, you do research, you teach, so it's a bit different.
So just a follow-up question about that. Would you go back to working in the industry after having your experience with the academia?
That's a very difficult question.
I know.
That's a very difficult question. Well, I guess the reason that I've stayed in academia is because I get used to the work that I'm doing and I enjoy teaching a lot. But it doesn't mean that if I have to go back to industry and even start from programming, I wouldn't enjoy it. So it is a very difficult question to answer, really. But it's not end of the world if, I finish working in university and start doing the job in industry. I'm sure I will enjoy it the same.
I see. Because us as, again, starting off, we are allowed to do co-op, and me and Raf were initially still having this conversation as computer engineering or software engineering students. There are a lot of positions available, but then once you go into it, you're overwhelmed to a point where you don't know where to specialize in, right? So
yeah, that's right. I think it's because of the nature of software engineering, because it is a broad area. So you can be, you can specifically work in one area, become a very expert programmer. You may work in software design and never involve in coding. You may be software tester. So you have to think about how you create test cases that tests this software comprehensively. So it's a broad area, and I'm sure that you are overwhelmed, but you are young and you want to try everything to find out which area interests you more. So believe me, there is nothing to worry about. You find your way.
I see. So would you say you were able to get a taste of all the things that you were initially interested in?
I guess I did, because, well, I know that from all the activities in software engineering, if I want to go back to industry, I know what I'm going to do. I would either be a database developer, or perhaps a programmer. So I don't want to work as a requirement engineer. I like it. I like the challenge. But if I'm going to choose one area specifically, I prefer to do programming or database design over, requirement engineering or testing. You see, or software design. This is something that you will learn when you work quite a bit. So yeah, I guess after you work, you know exactly what you're gonna do.
I think for a majority of people, especially the ones that I hang around with, there's always this hype around the big Silicon Valleys, right? We're talking about Facebook, Amazon, Netflix, and all that. So have you ever worked in those industries, or if you've not, would you ever work in those industries?
Well, I didn't have a chance to work in these, industries with big names. And well, if I have a chance, why not? I'm sure it will be a different culture from, the industry that I worked in. So why not try it? Well, it doesn't mean that, if you want to call yourself successful, you have to work in the companies with big name. No, that is not true. You can do so many meaningful things in a very small company. And after all these companies were small sometime, right?
I 100% agree with that.
Yeah.
Yeah, I mean, you never know. You could be working for the next Google, right? But I think for
Yeah.
majority of people, they're getting tunneled on the part of making connections. And on top of that, there's obviously the financial aspect of it as well, right? If you work there and
That
then,
is
yeah,
correct.
that's
That is correct. But again, you don't expect to get the highest salary even if you are employed in Google when you just graduated from university, right? So, of course, this financial aspect is important, but again, it all depends on your experience, years of experience. So you never know if you work in a medium-sized company or a small company for a couple of years and gain enough experience, and then you apply for Google, Amazon, or Facebook with loads of experience, then you will have a really high salary.
So it basically what you're saying, it matters on your experience and where you get into that job at that point, right?
Definitely. Experience is very important. Plus, for companies like Google or I guess Facebook or Amazon, it is very important that you know the science of computing. So this is important as well.
Yeah, you're right. So going back again on that, after your experience with the industry and with academia, what would you say what were some of the bad things of working in the industry compared to being in the academia? Some of the cons, let's say, I guess.
Okay, so if you work in industry and you are not self-employed, you're working for a company. Well, you don't have enough opportunity for research, right? So you have a question in mind. You don't have this time actually to do a research and find an answer to the question that you have in your mind. So in academia, it is part of your job. So you have a question in mind, you put it in a test, and you have time to do it. So this part is really enjoyable when you work in academia. Research is part of your work. In industry, unless you are working in research sector, you don't have this enough time to do research.
So in that sense, I can assume that you are doing research currently at York as well, right?
Well, right now I'm just doing pedagogy research, which means I do research to understand how can I teach better and how can you learn better. What methods should I use to make sure that you learn faster, you recall faster, and the material that you've learned stays longer? So this is the research that I'm doing now. Prior to coming to York University, my research area was something different.
Raf, you're muted. It happens to the best of us. It's okay.
I'm sorry. There's technical difficulties. Yeah, sorry, cut that off. So I was saying that Mabin and I actually had the opportunity to have you as an instructor for advanced object-oriented programming. That's EECS 2030 for those of you who don't know. And I quickly realized that programming is often considered to be daunting, right? And I think in my experience, I would even, and to many other people, it's either that they understand programming very well or they completely misunderstand it and they're just lost completely, right? I mean, I don't know if you remember that assignment that we had about that recursive car solution thing. That one, that gave me, honestly, that was like such a big challenging thing for me because I didn't understand recursion at all. So I was contemplating, man, is software engineering for me? Is it not meant for me? Because I'm like, I talk to other people, I'm like, this is something that I should get. I'm like, I don't get it. But from your experience as a prof, right? What causes coding or just programming in general, computer science in general, to be viewed as a difficult task?
Okay, so I want to elaborate on that because I do research in this area, so I know exactly where the problem is. Yes, programming is difficult. The nature of this course is different from any other courses that you will have in your program. But let me separate the concept. Programming has two parts. One is computational thinking, or in other words, algorithmic thinking or algorithm design. And the second part is converting this algorithm to a program. This second part is actually an easy part. If I write an algorithm in pseudocode and give it to you for that self-driving car example that you mentioned, if I write the algorithm in pseudocode and give it to you, I'm sure you will write the code in no time, because converting the algorithm to the code is really easy. If you know how to design an algorithm, then you don't need to spend a lot of time learning different languages. Maybe in a week or two, you can learn a new language. This part is really easy, okay? The problem is in computational thinking. And the research shows the only effective way that helps you in this part is practice. The more you practice, you become a better designer. You actually can solve the problem, can design algorithm better, and I can say you can design a higher performance algorithm. So yes, it is a daunting task. It's because that part, algorithmic thinking, is not an easy part. Most of the job that we do, we do it unconsciously. So I tell you what is 2 + 2. You will quickly say it's 4. In programming, I say, no, wait a minute. It's not like that. Tell me, how did you find the solution? You need to tell me that, okay, when you said 2 + 2, I put 2 somewhere in my memory. I put number 2 in another part of memory. I know how to process addition, so I fetch this number 2 from my memory, I fetch this number 2 from the other part of memory, and then I process it. This is the difficult part. The difficult part is how to break down the problem into its component. This is something that is not usual in everyday work that we do. And that's the reason programming is difficult.
So how would one develop a really good computational thinking?
Practice, practice, practice. It is a skill. You know, if you want to play piano, the first day, the sound is not something that you want to hear. The second day, the first week, the second week, you cannot play it well. After a year, you can play a nice music. You want to learn how to drive. Well, the first day, you cannot go even in a straight line. But after a week, you can drive really good. Why this happened? Because you practiced, and this is the skill that you gain when you practice it. This is the same for programming. If you want to get better, practice.
Yeah, I think I would agree to that. But then for me, at a certain point, if I were to hop on like Lead Code or HackerRank and try multiple questions here and there, trying flipping nodes and flipping trees and stuff, at one point I would get stumped if it's like a very brand new question, right? If it's a question that's out of the blue and it's not something that's covered under the circle of things that I've practiced. How would you say you would tackle that? Would you say that only develops as you do those questions that you're comfortable with?
Well, I spend time and practice different, solution. Do you think I can solve a new problem just like that when I see a problem? No, that's not true. I have to work on it. I have to spend time. Yes, that is true. Sometimes for a difficult question, competition question, I spend a lot of time to find the right algorithm to solve it. So this is true for me as well. If you want to solve a problem, you need to practice and give it a time, work on it to find a solution, and never get disappointed on yourself.
I think it's just very daunting because when I would try those lead code questions and I would see the difficulty is that easy. And I saw how much time it took me to type. It's like really, really daunting, right? So outside of the computational thinking part, is there a particular topic that you notice most students struggle in? Whether is it aggregation? What is it? Is it the recursion part? What is it that they struggle the most in?
Recursion. Recursion is the most difficult part. And I tell you what, when you learn about computational thinking, it's a new mode of thinking, and you haven't get used to that. We introduce even a newer mode of thinking. So yes, recursion, I guess, was the most difficult part, or this is the part that the student struggle the most.
Yeah, I could definitely agree on that. Like I said before, that was personally something that I struggled as well. And that is for those of you who are also in software, that is something that you will need in data structures and onwards. So
that's right.
Yeah, you definitely have to watch out for recursions, people. For me,
and this is something that I really enjoy teaching. So if they have a question in recursion, they should ask me. I enjoy, answering the question about recursion because I enjoy teaching this topic.
Also, for people that will be having her as professor in your future courses, she actually likes it so much she's willing to give out points and marks for asking questions.
That's right.
For me, I had this one high school teacher who said computers are extremely dumb and you just have to give it really, really, really simple information to help it understand. But the point is, us humans can't give out simple information because we're not trained to think, so we do things just subconsciously. So you're right, just that computational thinking only comes with experience and practice.
Yeah, I mean, that's at the end of the day, practice is what makes you perfect, right? Yes. And aside from the students as well, I know that students obviously have to do a majority of the learning. Do you think there are any tips that you can give to other professors or teachers to help students learn?
Well, these days we've realized that one thing that helps students learn better is to have an element of active learning in all classes. So before we just had a lecture and we talked for 1 hour and a half or 2 hours, and then we had some problem that the student needed to solve and submit it. Right now, we find out that, if instead of teaching, we ask the student to solve a problem, it sticks better. So something that we do, and we spend a lot of time when we prepare for our lecture, is to design activities that students do it in the lecture. So while they're doing the activity, they learn something, and the professor is available. If they have a problem, they can ask professor. So I guess my suggestion is to have an element of active learning in their courses.
When you say implement active learning, how has that implementation is it being impacted by COVID? Because I know for our courses, I never had to pick up a pencil or a piece of paper. We just had to either type or, just use a PDF to put numbers onto memory stacks and stuff like that, right?
Yeah.
So, well, since it's online and everything's remote, it's much easier. You're at home and you can just click with the click of a button, you can submit, you can retrieve and download stuff. Would you say COVID has affected any of your classes, or how so?
Yes, it did. So prior to COVID, I would print all these questions on a paper. I distributed in my lecture, and I told my student that you're not allowed to use computer. So you use pen and paper to solve this problem. And I actually realized in one of my sections in 2030 that one of my students actually ran the code and find the solution. And I said, no, this is not the goal of, this is not this is not what we're looking for. We want you to get away from your computer, or assume that you get away from your computer, because in COVID situation, we didn't have any other choice. You don't use, any programming editor, and you don't compile the code. You just want to see what happens behind the scene. So I want you to test your understanding. That's why I say we use pen and paper. So in COVID situation, we couldn't do that. So I had to convert my question to a version that I could upload it in the learning management system. And well, some students follow the instruction, and then they never used, an editor to run the code, but some students did not follow this instruction. Yes, COVID has affected that as well.
I mean, outside of the those active learning exercises, I'm sure you're aware of those. There's a growing popularity for online and self-taught learning, right? I can name a few in my head right now. There's Udemy. There's even one Coursera. There's many things, right? And there's actually so many debates as whether going to university to become a software engineer is even worth it at this point, right? Is there something that separates, in your opinion, a university courses from those platforms?
I guess yes. There are some reasons that you go to university to learn all this. The thing is, let's say you want to learn how to develop an app and a mobile application. Okay, you can find plenty of courses in Coursera or Udemy. Okay, you learn it, and after a while, you can actually develop an app. But you can develop an app, but does it mean that you are an expert? No, because at university, we have a package. First, we start with computational thinking, object-oriented design, and things like that. Then when you learn that, we have another course called algorithm design and analysis, or something like that, in which you learn about program complexity. So you learn that not all the programs that solve a problem are a good program. So this is something that makes you different from somebody who has taken a course in Coursera or Udemy, because we provide a package. We think about what you need to be an expert, what kind of skills you need to acquire to be an expert. Then we design our courses in a way that you actually achieve these skills in different courses. Also, there is another thing. Have you thought about your career path? At university, you are in a class of 100 people. You are making connection with these people. This is important. This is something that doesn't happen in online courses. Just imagine that one of your friend, the person who sits next to you, after a while goes to Google and starts working there. You know, you have a connection, right? So this is another good thing about being in university.
So you would say university courses kind of focuses on the fundamentals to initially start off
Yes.
with, right?
Yes.
And then eventually builds out to what catches people's eyes, like user interfaces and apps and websites and stuff.
Exactly. So you as I said, we have a package. You learn everything that you learn the basics of everything that you need to be an expert. So if you want to be an expert, you need to take that many courses in Coursera or Udemy, if you're lucky enough and you know which courses you should take.
I think more importantly as well, not only do they teach you for example, the algorithm complexity analysis courses, not only do they teach you the computer science behind programming as well, but more importantly, like you said, that not every single solution might be the optimal solution, right? So in some sense, I think it really teaches you how to write cleaner codes. Yes. Right. I think in some of the forums that I've seen, just because they accomplish something using a double for loop, and they automatically think, oh yeah, you know what, that is the best thing ever. We're gonna leave it at that, right? But most people probably won't realize that actually runs in quadratic time, right? Yes. So there's that whole analysis that have to go into it as well. And I think that's what those courses don't really teach, right? They just they teach mostly syntax.
Yes, that's right.
Right. So out of the courses that you teach, right, do you typically, which one do you typically enjoy the most? And is there a course that you somewhat dislike teaching?
Well, anything related to software engineering is something that I enjoy the most. So starting from first year, yes, computational thinking, second year, object-oriented design, going up, data structures and algorithm, software engineering course itself, software testing is something that I enjoy a lot. User interface design is something that, again, I enjoy a lot. So yeah, anything that is related to software engineering, or in another word, any course that I have something to say from my past experience is something that I enjoy a lot. You know, when I'm teaching programming, I've seen so many problems. I can talk about it. When I teach database design, I can talk about, how to write a secure SQL statement. And I can give you an example of a SQL injection attack. You know, something that comes from my background experience, something that I can talk about is the course that I enjoy the most. Something that I don't dislike, well, I cannot say there is a course that I dislike because I love teaching. So even a course is new for me, I will find a way to enjoy it.
This might be a little too controversial, but what are your thoughts on discrete mathematics? It is a course that us as second years have been through, I would say 2 courses, right, Raf?
Yeah, the first year we took a discrete math, and then the second one we had to take a logic class. So I think that would be 2 years in a row, yeah.
I'm pretty sure that I would love to teach this course for 2 reasons. First, discrete math is the fundamental for, algorithm design. And I remember it was an easy course for me when I did my undergraduate. And the second, it's maths, discrete maths. I love teaching maths. So yeah, I'm pretty sure I will enjoy it.
Okay, so I guess, Raf, we need to start a petition to make her teach discrete or something.
Yeah, something needs to be done, man. But have you ever thought of thinking, of teaching EECS 1011? That's the introduction to programming for engineers.
Well, I have taught this course more than 10 years and more than 20 times in different languages. Java, C, Python. Well, I don't remember the early languages that I used to teach. So, yeah, why not?
There's many of the people we've talked to in Lausanne are very confused as to why MATLAB is used to teach introductory programming. I know it's very complementary for those who are maybe in mechanical or those who are going outside of EECS, but we often think that a more mainstream language, like let's say Python, should be used, right? Because it just gives students better and stronger resume skills especially when they're going to their second year, right?
Yeah.
Instead of having naming down MATLAB then Java, it's going to be Python and then Java, right? What's your opinion on this?
Well, if I had to choose, I would probably choose Python, but I don't know what was the rationale behind, choosing MATLAB for the first year. When we decide on something, it's not like I like to do this, I like to do that. We have to discuss it in our faculty meeting and we have to talk about advantages and disadvantages. So I'm not aware of the rationale behind it because I wasn't in York University when they decided to do that. But I'm pretty sure that there was something good about MATLAB, maybe the simplicity of MATLAB. Remember I talked about programming has two parts. One is computational thinking and one is the syntax. And this part, it's not difficult. Maybe the rationale was that choose something really simple that students don't want to think about this part and focus on computational thinking. I don't know. It's just my guess. So maybe that was the rationale, maybe because MATLAB is simpler than Python. But the last time that I worked with Python, I guess it was in 2002. And the last time that I worked with Python was 2 years ago. So if I'm to choose, I probably choose Python.
So basing on those comments, would Python be your favorite language to work with?
My favorite language? No, my favorite language is Java. Because I like object-oriented programming. I know that with Python, you can, create programs in object-oriented, but it's not, every principles of object-oriented programming that is discussed in the textbook and everywhere, you can see it in Java, you cannot see it in Python. So because I love this paradigm, I love this paradigm of programming, which is object-oriented programming, I guess my favorite language is Java.
Right. I would agree with you on those because the way I see it, it's more of like Java is the English language, right? And Python would be more like the slangs. So
Yes.
before you can learn the slang, you have to know some of the formality, right? You can't go from the slang, then learn formality, right? That's just how I see it, right? Yes. Okay, for this next portion, we're going to be asking some Discord questions. Mm-hmm. We asked people from the Lausanne Engineering Society's own server. There are some people that are interested in asking questions as well. Mm-hmm. The first one being that in their own quote, I have noticed that a lot of companies require us to know some frameworks. Example would be React, Angular, and Vue.js, all JavaScript related for our co-op jobs. Shouldn't most universities incorporate these concepts into their programming courses? Better yet, shouldn't there be separate courses for these in lower years?
Well, we try to do that, but the thing is, we have limited time and we have so many things that we want to talk about in 4 years. So whenever it is possible, we talk about something that is popular in industry. For example, in software engineering course, we ask you to work with GitHub, or in 2031, we ask you to work with Linux operating system. So whenever time allows, we try to add the things that are most popular in industry into our courses. In perfect world, I wish we could teach you everything, but that is not possible because we have limited number of courses and you don't want to stay in university forever. So I guess that's the reason that we cannot have everything in our courses.
Yeah, and just to add on that answer as well, I think that the main way for you to learn this is that when you're applying for jobs, creating your resume, you make your own projects, and in those projects, you then use those frameworks so that you apply the knowledge along with your computational thinking and let's say your React knowledge to design an app or a website as well.
And also, capstone projects are always a good opportunity to try something new. So if you are going to develop a software, why not use one of the new frameworks instead of sticking to something that you've learned at university?
I feel like this is where those courses come in. Even though they might not be fundamental or they might like focus on a specific objective, I've found much simpler courses that just introduces you to specific frameworks. And I feel like this is where a mix of university education and courses like that come in, especially in our field, which is like always growing and it's clearly it doesn't have a sign of stopping anytime soon.
Yeah, it doesn't stop. Yeah,
so I feel like this is where you could use a mix of both and get the taste of both worlds and eventually actually just make yourself better and know more about it.
Yeah, that's right. Well, as I said, if from time to time, we change our courses and we add some new material. We actually get rid of some old material. We do that, but we cannot have everything all in one program.
All right, fair enough. Second question comes from somebody that is really, really interested in about learning different programming language. And they asked, what are your top 5 programming languages that every single software engineer must know and why?
Okay, I prefer to say what are programming paradigms that software engineering should know and should be familiar with. I guess all software engineering should be familiar with object-oriented programming. So a language in object-oriented programming could be Java, C++. Everybody should be familiar with procedural language. I suggest C and Python. Especially I suggest C because you get to learn what is happening behind the scene because you work with pointers, you work with memory directly, and that gives you a vision on what is happening when you write a code. And this will help you when you debug a code, not only in C, but also in other programming languages. Also, I guess you should be familiar with one functional programming language like Lisp, Haskell. And as an icing on a cake, it's good to be familiar with one visual programming language like Alice or Scratch. You may not use it, but it's good that you are familiar with it. So Java, Python, C, Lisp, and scratch. So that is 5.
Yeah, that's a really interesting take on it, because everywhere you go is like, hey, what's the best languages that you know? What do you think is the best language? Never really thought about the fundamentals of those languages, right? And what are the fundamentals that you should focus on? That's a really good take on that. Yeah. Another question that we have is, throughout your career as an professional, have you ever used any of the complex data structures such as red-black tree, heaps, graphs, and etc.? I've done a co-op term, and the most I've used were linear ones like the array list. End of quote. Thoughts on that?
Okay, don't tell me that you asked this question because you want to say, okay, I never used this, why should I learn it? Okay, so it all depends on what are you doing. If you work in a game development company, for sure you will use all this complex structure. You will use graphs, you will use trees, and all related algorithm. For myself, the industry that I was in, the most complex structure that I used directly was multidimensional arrays. But indirectly, I used other structure. For example, when I use a library that uses a heap sort, I'm actually using a tree data structure, right? I'm using it indirectly. Somebody else has written it for me. I'm using a library that sorts the data using heap sort. So I may not use it directly, but indirectly, yes, you will use it.
So I would say it's mostly, again, being still, even if you are not, even in the position that you are in, you might not be using it. Somehow you would be still indirectly using it. And it's always great to kind of know that fundamentals, right?
Yes, that's right. And also, as I said, it all depends on the type of the work that you do. If you work in game development companies, you will most definitely use this complex data structure.
Awesome. Well, those are the questions that we have for you. And I think this is a very good point to end our episode. Is there anything you would like to anything that you would like to say to end the episode with, Miss?
Well, I just want to thank you for giving me this opportunity. Stay safe. I think this is something that I can say in this time. Please stay safe.
I think that is very well put together. Thank you, Miss. If people need to contact you, where can we find them? We could put that in our social medias. Any links?
They can always contact me via my university email, but I am in social media as well. I'm not really active, but I'm there, and my ID is the same as my York University ID. My email is Marzieh A. Marzieh, my name, and A is the first letter of my family name. I use the same ID in social media, and they can find me there. However, I'm not very active there, but you can find me there.
All right, we will put those in our descriptions. And I think that is a very good point to end our episode. That is all we have. Everyone, as she said, stay safe. Thank you.
Thank you.